Continuing with the addition method to solve a system of equations. Here I have a 4x and a 3x. Here I have a 5y and a negative 2y. So I want to get either the x's or the y's to have opposite coefficients. So you know what? If I multiply this whole equation by 2, and if I multiply this whole equation by 5, I'll get 10y and negative 10y. Where did I get the 2 and the 5? Multiply this equation by 2. And then multiply the second equation by 5. I was looking at the coefficients of the two equations. So I'll rewrite the original equation. 4x plus 5y is going to equal 14, and 3x minus 2y is going to equal negative 1. I could have done the same for the x's. I would multiply this top equation by 3 and this bottom equation by maybe negative 4. These already had the opposite signs. If they don't have opposite signs, you have to multiply by a negative number to get one of them to be opposite signs. All right. So, if I multiply this whole equation by 2 and this whole equation by 5, I should get my y's to cancel. So an equivalent system would be 8x plus 10y equals 28. All I did was distribute the 2's. And my second equation would become 15x minus 10y equals negative 5. All I did was distribute the 5. Now I'm going to add vertically. 8x and 15x becomes 23x, and my y's cancel. And 28 minus 5 is 23. So I have 23x equals 23. Let's get x by itself. Divide both sides by 23. And I get x equals 1. So now I go back to either equation and substitute in a 1 for x to find my y. Here I picked the first equation. 4x plus 5y, and I substituted the 1 in for the x. 4 times 1 is 4 plus 5y equals 14. And let's subtract 4 from both sides, and I get 5y equals 10. Divide both sides by 5, and I get y equals 2. So there is a single solution to this system, and it is the ordered pair 1, 2. X is 1, y is 2. So you're going to try practice 5, where you probably have to multiply both equations by a number. All right, and example 6. Let's take a look here. All right, I have a 2x and a negative 4x. I have a negative 3y and a 6y. All right, I think I'm going to multiply this equation by 2. So then I'll get a 4x and a negative 4x. So I'm rewriting the equation. 2x minus 3y equals 6. And then negative 4x plus 6y is going to equal 5. And I've decided I'd better multiply this whole equation by 2. Let's distribute the 2. 4x minus 6y equals 12. Don't forget to distribute to both sides of the equal sign. And negative 4x plus 6y equals 5. Now, when I add vertically, my x's are going to cancel, but you know what? My y's cancel, and I get 0 equals 17. When will 0 equal 17? Never. So I would say there is no solution to this system. There's no value for x and y that would ever make both equations true at the same time. So we've completed learning the addition method.